Are we live yet? Oh, we're live. We're live. Hopefully, we're live. Okay, we're live. Okay, what's up, guys? Mike the Coder here. Sorry, guys, I came in late. Sorry for streaming 1 hour late. Yeah, I was originally supposed to stream at actually 2 hours ago, but now it's 1 hour late. 2 hours late, my bad. It's like I was trying to do something with my PS2. I was trying to mod it, soft mod it. But yeah, so what we're doing in this live stream is that we are going to, I made a list of all the problems that I've solved, and we're just gonna resolve them. I don't know if I should do other problems. I could make a video talking about my Google interview on how I bombed one question and after that I got a rejection. But I could talk about that later. But yeah, what was the Google spreadsheet? Yeah, I made a list of all the LeetCode problems I've solved, the medium problems. And then I read this article saying that from FFT that you should actually not look at the solution. You should actually try to do it yourself. So I'm going to try to do that now. So from now on, I'm going to resolve the LeetCode problems, and then I'm going to, after resolving the LeetCode problems, from now on, I'm just going to do the problems by myself. Because I feel like that's the only way to actually learn things. But yeah, so I made a list of all the 100 problems that I've solved before, and I'm just going to redo them. It's only 132-ish, so that's actually not that bad. Yeah, and then also some of these problems I think I already know how to do them. So we'll just go try to breeze through them and see if we could do them. If not, we'll just skip by. And I think I'm going to stream for an hour or two, because then it's already 12:30 for me. But yeah, I wonder what time it is for you guys. Originally, I don't think anyone's in this chat. Well, no one's here anyway. So, okay, you're given an array nums and an array queries where the queries I, val, and index. For each query, we first apply nums at index I equal nums at index I plus val. Then print the sum of the even values of nums. Return an integer array where answer I is the answer of the ith query. What does that even mean? For each query I, we apply. So we have queries of val I and index I. For each query, we apply nums at index I is equal to nums at index I plus val I. Oh. Okay, so we're just applying this operation. So for each query, I first apply this, then print the sum of the even values of nums. Return an integer array where answer I is the answer to the ith query. Okay, sure thing. Okay, this is not hard. So let's just create an integer array ants ith query. So we're gonna it's gonna be size. I believe it'll be size. Now we're just gonna loop through each query. So we have two integers. I think it's the val. So let's just split them up. So val is equal to queries at I at 0. And then we have, what is the next one? Index is equal to queries I at 1. Okay, and then now what we're going to do is we're just going to apply this operation. So we're going to do nums at index is equal to nums at index plus val. And is that it? Then print the sum of the even value. No. Then print the sum. For each query, I first apply it in the operation. Then print the sum of the even values of nums. Okay, so after adding 1, the array is this. And then the sum of even values is 8. Oh. 2, 4. Oh, okay. So then for here, we do Oh, this is gonna TLE though. Let's see, sum nums at j. Oh, the even values. Okay, so we're just gonna sum up the even values here, and then we're just gonna set the query answer at the queries is gonna equal to this. So then ants at I is gonna equal to sum, and then here we return ants. Okay, so yeah, apply the operation. We're gonna loop through it, get the even numbers, some even numbers, and then we just return it. I don't even know if this will TLE. Okay, so it did TLE. Okay. So there's a way to make this faster. Let's see if there's a way to make this faster. Anyone in the chat? Oh, there's people in the chat. Oh, video quality is bad. Okay, my bad. My bad. Video quality is bad. My bad. Ah, that's funny. Can you even see me? I have no idea. Can you guys see? Can you see the? Here, maybe I felt I just like cut the other parts. Okay, so this is like the most brute force way to do it. Let's just see if like there's an easier way. So if we apply the ith query to j, yeah, I could think of like one way we could make this faster. What if we just sum up all the values originally, like total sum? So like let's say I have 1, 2, 3, 4, right? What if I sum up 1 plus 2 plus 3 plus 4? So that gets me like 10, and then after the first operation you get 2, 2, 3, 4. So what does that give you? That gives you 11, right? And the even numbers is 8. Okay, so what if I sum up the even numbers first? So let's say I do 2 plus 4. So from 1, 2, 3. Okay, so from here 1, 2, 3, right? Do you guys see this? I don't even know. So I have 1, 2, 3, and let's say I sum the even numbers. So I have 2 plus 4. So it gives me 6. So, and then let's say this query happens at, what was it, 1, 0. Add 1 to number 0. So if this is odd, we're not going to do anything to it, right? Add 1 to number 0 gives you 2. Oh, wait. That increased your 6 plus 1. No, that made it odd. Let's see, what could we do? Another thing, we could make it even. We could have a Boolean array representing odd and even, and then anytime you add to an even number to an odd value, that's when we have to add it. No, an odd number to an odd plus, so 3 plus 2. 3 plus 3, yeah. If you add an odd number to an odd number, that's when it matters. So yeah, we could try that. I think that would work. So here we have 1, 2, 3, 4. If let's say I create a Boolean array representing like true and false. For if it's odd, it's true. If it's even, 0. Then if when I do the query, if it's an odd number, we're going to add to it, right? But then when we add to it, we need to plus 1 to the we need to re-add this value. So let's say it was like 6. So let's say we start the sum of the even numbers in the beginning. So 2 plus 4 is 6. Then if this number 1, 0 is odd, and we add to it, we need to change this 6 into plus 2. So we would add whatever number it is here. And then if, let's say I took to an even number, so let's say I did -3 plus 1, which is even, so then this would become odd, and then we will subtract. So it is 4, 8. 8 minus 2. No, 8 minus 3 was not 6. Let's think. This is a good part about thinking. So, okay, so let's go back to here. So we have 1, 2, 3. Okay. Can you share this sheet link? This is just like all the problems I've solved before, mediums. I don't know if it's really useful for you guys. This is like all the stuff that I've done before. Maybe I'll share it later with you guys. It's really like not, I don't know if it'll be super helpful. Some of them I was doing blind 75, but a lot of these like aren't super duper helpful. This is just like from my own sake, of my own sanity to resolve things. But yeah, okay, so I could share the link to the spreadsheet link. Okay, so anyway, let's go back to this. So yeah, back to this. Okay, so we have 1, 2, 3, 4. So we have 1, 2, 3, 4. 1, 2, 3, 4. And then the query. So let's say we had like, why is this? Let's say we create a Boolean array representing 1 if it's odd. So this is our odd or even array. So this is odd, even. And then let's say that we go through a query. So we have 1, 0. So let's just pre-compute, add up all the evens, because that's what we want, right? In the end, sum of even numbers, right? So if I just do 2 plus 4, that'll give me 6. So this is like even sum. So I have the evens. Now if the array is, okay, so if we're at 1, 1, 0, so let's say I give me a 1, 0. So what we could do is we could check if this is even or if it's odd. So if it's odd, like with our Boolean, right? So if I see at the 0th index, this is odd, right? So if I do +1 to an odd, this will give me 2, right? And then the answer is 8. See, the first answer is 8. So what we could do is we could just add whatever values here after adding to this into our total sum. So that'll do +2, which is 6 plus 2, which gives me 8. And I could just put that there. Let's try like other ways to do it. 2, -1, 3, 4. Okay, so this is -3, 1. So let's say we're at -3, 1 now. So here this became 8. So -3. Wait, -3. Oh, -3, 1. Okay, so this is positive. -3, 1. Okay, so at 1, we see this is even. So they -3, which would give me -1. So because it's even, we actually have to subtract. Wait, so this one. Oh, whoops! This one became a 2. My bad. Just became a 2, not an 8. We have to subtract 1 from 6, I believe, right? No. It would just become. Oh wait, +2. Okay, so this became +2. So this is 8, right? So we add 3, -3, 1. So if 1 is even, so at index 1, this is actually even, yeah. So if it's even, -3, 2 minus 3 is -1. If this, how did they get that answer? 2 plus 4 is plus 6. Okay, there must be a faster way to do this. I was thinking like we could take 8 and then minus 3, but 8 minus 3 is not 6. Oh, we could take 8 minus 1. No, we can't do that. How does this affect the total sum of even numbers, though? That's a big question. Can we do 3 minus... Okay, minus 3 plus... Let's go back here. Minus 3 plus 2 is minus 1. And this became 6. How does this affect the total sum? Total sum was 8. After you got rid of this... Oh! Okay, so if it's odd... Okay. Okay, so if minus 3 and this was even, right? So if minus 3 plus 2 is negative 1, if this value is odd, then we remove the 2 from our total sum. So here we added 2 in the first place. Now we subtract 2. Yeah. I believe that would work. Okay. So that would be 8 minus 2 would be 6. Okay. Yeah, I think this would work. Okay, so the algorithm would be something like, I'm literally just making this on the top of my head. I really don't remember this. Yeah, sum of even numbers. What? Yeah, so if you, okay, I need like a new sheet. Okay, where I need like a new thing. Where do I see this? Oh, but I want to save this though. Is there a way to get a new one? Okay, I'll just do it on Visual Studio. Actually, I'll just do it on LeetCode. Okay, so keep a total sum of the current thing. Keep track of the original total sum, right? If it's even, so there's two cases. Okay, so if the original number is even, no, my bad. If the original number is if the original number is odd, we're gonna take the current sum 6 and add it with 1 plus 1 gets 2. So add it with like the new sum of the original number in it. If the current sum is even, like if the current number is even, then we're gonna take -3, add it with this, and you get -1. We'll subtract the original number. Okay, so okay, man, I hopefully I remember that. Okay, so if keep track of the original totals of the original total sum of evens. Okay, if the original number is even, is odd. If the original number is odd, we're going to add, take the current number and add it with it, right? So we would take the current number and add it with the new number that we're adding, and then we'll add that to our total sum. So take the current number, add it to the query, and add it to our total sum of evens, right? So that's that part. And okay, so that's that part. Oh, whoops. And then if it's odd, oh, that was odd, my bad. Now, if it's even, if the original number is even, we're gonna take the, oh my gosh, I'm blanking out right now. Oh, we just subtract by the original number, right? Because if it's even, so if it was even 2, right, and we did 2 minus 3, gives me -1. What we did with our total sum was we just got rid of the original number, right? Oh, but the issue is that if we add it, crap. The issue is that if we add it with like so if it was 2 and then it was -4, that gets you -2, and then you have to subtract it from the total even. Actually, let's just see if this works. I don't know. Remove the original number from total sum. Okay, there's more test cases we have to think about, but let's just see if this works. Okay, so we're gonna loop through nums. So we're gonna call this like even total sum. Crap. So I have to check if this is even. Okay, so this is even. Yeah, even total sum. Okay, so this is like the original one. Now, okay, this part is where it gets harder. Okay, so here, this is when we update the query. That's the part where we have to think about. Okay, so if the original number is odd, so if this number is it odd? Okay. If it's odd, take the current number and its square and add it to our total sum of evens. Yeah, so that's like the case when 1 plus 1 gives me 2, so then we add it with 6. My only issue is if it was like 1 plus 2 though, like if I'm updating 2, that gives me 3, then I have to subtract out of 6, right? Because then, wait, no, I wouldn't do anything at that point. Wait, oh my god. Okay. This is so hard. Okay, wait. Okay, for now, let's just think of this only test case, okay? I'm pretty sure this would be wrong, but I need to code this up, otherwise I'm going to forget what I'm doing, okay? Nums at index plus val, okay? So this is like our number result. Then what was it? So if with 1, 1, right? So I took 1 and I updated 1 plus 1, I get me 2. And then my current sum of 6 had to be added by 2. So I'm going to plus equal to result. Our even total sum plus equal result. Okay? All right. I should also just update this. Yeah, well, I mean, you got to update it anyway. This is going to equal the total sum. All right. Otherwise, if it's even, what did we say before? If it's even 2, what was it? Okay, so crap. We have 1, 2, 3, 4. If it's even, I take 2 and then I minus 3, right? That gives me -1. Then I just have to remove my original number of 2 because that doesn't affect the sum anymore. So then we just do total sum minus equal the original number. So the original number, which would be nums at index. Okay. I'm pretty sure this would not work in some cases, but what is a compile error? Wait, what the? Oh. Oh, whoops. Man, I misspelled it twice. It's crazy. Okay, yeah, so this makes sense. We get wrong answer. Yeah, that's right. That's because, like, there's certain... Okay, so there's original number with the new number is odd. Original number with new number is even. I don't know. We have to think of, like, 2 more cases. Keep track of the previous values while looping through queries. I mean, then we could check the condition for each of them. Odd, even. Yeah. That's what I was thinking. That's what I was thinking. Yeah. Yeah. Thanks for that. It's Miyaki. Okay. Yes. Okay. Yeah. Okay. Okay. So. Oh crap. Okay. Let's go back to this. So 2 minus 3 would be -1. If this number is odd, then we get rid of the original number of 2. 2 minus 3 minus 4. So it would be 8 minus 2. Okay. If 1, let's see, if 1 plus 1 is 2 is even, we add it. 2. Oh, so we could just do 2 cases, I think. What if we do this? Okay, I'm gonna comment this out real quick. What if I just do like result is equal to nums at index plus val, and we just need to check if this result is even, or like if our update is even. So if it's even, we're gonna if it's even, we add it to our even total sum. If it's odd, we subtract the original. Hopefully this works. Ah, damn, still wrong answer. Okay, yeah, okay, then we actually have to break it down to the test cases. Okay, oh boy. All right, let's actually see what's going on here. Let's see. Okay, let's actually break this down. Okay. Man, this is hard. Okay, 1, 2, 3, 4. All right, I'm gonna read the chat after when I try to solve this. So our sum is gonna be 6. Even sums. Okay, we have 1 and then 0. So 1, 0 converts this into 2. So 1 plus 1 gives me 2. So 1 plus 1 gives me 2. Okay, so 2. So this becomes 6 plus 2 should give me 8. Okay. What is the next query? -3 and 1. Okay, so -3 and 1. -3 is at 1, so we take this, -3. 2 minus 3 gives me -1. So this gives me -1. Okay, and then this got rid of this 2, so this 8 minus 2 gives me 6. Okay, so that was this part. Okay, -4, 0. Let's see, -4, 0. Okay, so here 2 minus 4 gives me -2. Yeah, so 2 minus 4 gives me -2. And currently our total sum is like 6. Oh, my bad. So 6. Do we -2 from 6? Oh, no, we don't. Wait. We have 6. 4 -2 plus 4 becomes... Oh. Okay, so originally is 2 plus 4 is 6. Okay, originally 6 was right. When we converted this 2 to become 2 minus 4 is -2. We made this negative. Oh shit. My battery's running low. No. Okay, I'm gonna be right back. I gotta get my charger. Hopefully this stream doesn't die. Yeah. I'll read the chat real quick. If only previous index subtract, and if now is add now, I guess. I'm not sure. If both are even, we subtract the difference of the two values, I think. So if s minus equal to previous minus now. Can you share the problem link? Yeah, I think you're right. I think that makes sense. Mayuki, yeah. Can you share the problem link? The problem link is, oh yeah, here, I'll share the problem link. I think it's this one. I'll just pin it. I think it's this. Actually, I legit have to get my charger though, because my battery's actually gonna die now. Holy crap. Okay, I'll pin the problem link real quick. Do this, and I'll just pin it. All right, I'm gonna be back real quick. And I'm gonna get my charger. But yeah. Whoops. Hello? You guys hear me now? Hello? Anybody there? Alright, I'm just gonna hope that you guys hear me. Hopefully. Let's turn the video on. Can you hear me? Let's see. 8 concurrent views. Holy shit. That's way longer than I had before. Can you hear me? Okay, I'm just gonna... Okay. Now we're actually back. I think we're legit back. I think so. Okay, so... Yeah, back to this. If we take current sum, so we have 6, and then we take 1. 1 plus 1 gives me 2. So at this part, I had to add 1 plus 1 plus to the original sum of 6, which gives me 8. Now when it was 2 minus 3, that gives me negative 1. So I had to subtract 2 from 8 to give me 6. Okay? Because negative 1 was odd. So I subtracted to the original number. So if yeah, I subtracted the original number. But also what's weird is that when you do negative 4, when you do negative 4, 0, negative 2 minus negative 4 gives me minus 2. So we're not supposed to add it by 6. We actually have to subtract 4 from 6. The query. So here 2. Oh, okay. So we just update the query. So 2. So when it was 2 minus 3, we get minus 1. We subtracted the original number. When it was 1 plus 1 was 2. Okay, so if the original number is so there's 4 cases. Okay, so let's actually break this down. If original number, so let's actually create like a variable called original number, nums at index. So if original number is even, okay, so if the original number is even and the query number is odd, we're going to remove the we'll minus 2 from our total sum. So and the query is odd. So and what was the query is odd? Nums. What was it? Val. We are going to subtract this, okay? So that was 2 minus 3 gives me minus 1, so we remove 2 from our total sum of 8. Okay? Else if original num mod by 2 is even, is not even, so if the original number is odd, and the query is odd, so 1 is odd, okay, so and the new query, or the, let's see, 1 plus 1, let's see, was it 1 plus 1, I think? Nums and val. Yeah, and the value is odd. Okay, so let's go back to missions. Okay, and the value is odd. So if this 2 minus 3, 1 plus 1 value is odd, then we are going to add it to our original number of 8. So going to add it to this. Yeah, so it would be this plus that. I could take the result, put up to the top. What else? Then there was also another thing. So if the original number is even and the new one, the value is also even, we are going to just update the value plus equals to our even number will plus equal to value. So yeah, so if and val mod 2 is even, we'll do even total sum plus equal to value, which is val. Okay, so it would be 2, yeah, it would be 6 minus 4, which gives us 2. And then there was one more, I think. It was 2, 2, 3. What is 2, 3? 0, 1, 2, 2, 2, 3. So the next one would be 2, 3. So here would, oh my god. So here would be 8 minus 2, which gives us 6. We need to subtract 2 from 3. Oh wow. Why is my pen not working now? Man, my pen's not working. That's weird. Okay. So here it would be 2 minus 2 minus 1, 3, 4. So if now it's going to be 2, 3. So this is 2, 3. So that adds 0, 1, 2. That converts this to 6, I think. Is that what it did? What was it? Yeah, it converts this to 0, 1, 2. 0, 1, 2. Wait, what was the query? 3. Oh, 0, 1, 2, 3. Oh, wait, the last one. 3 plus 2. Okay, so not 6. This one. 0, 1, 2, 3. This 4 became plus 2, so it became 6. So in that case, both of these are even, and at the end this was 4. I think 6 minus 2 was at the end this was 2. Right, 6 minus 4 will give you 2. I don't know why my pen's not working. Gives you 2. And then when we add by 2, wait, yeah, when we add by 2, we should, since they're both even, we should add it by, so this should be plus 2 should be 4. Yeah, okay. So yeah, I think this would work. Unless there's another case which I haven't thought of yet. Which I might, oh yeah, boom. That was it, yeah. Okay, yeah, okay. All right, yeah, this took a long time. I don't know. This is definitely not that fast. We could look at the solution now soon, but yeah, let's see what people eat. Yeah, we can see. Okay, yeah, that's great. That's great, guys. I hope you guys like could hear what I was saying. Did I freeze again? I don't even know. I can't even tell if I froze. Okay, so yeah, we solved the problem using a bunch of these cases. Here they said that it's not that fast, which I do agree. I'm gonna see like what their solution is. Yeah, let's just see like. But we did use very little memory, so let's actually see how they did it. Let's see the fastest solution. Rolling sum. Okay, oh, okay. If the current value is even, subtract it, then we add it. current value is even, we add it. Huh? I guess this was something that we just didn't see. I didn't think of or saw it yet. So the only thing that mattered was the rolling sum or the total sum. Wait. Okay, so it was the current value if the current value was even. Okay. Yeah, what I did wasn't efficient, but I mean, we had a lot of cases here, but I mean, it's still like, still all right, I guess. I mean, it was submitted. Okay, so yeah, so I have a list of problems that I gotta resolve. So here I'm gonna write AC to mean that I solved it. You guys should keep like a list of problems to resolve, a list of problems that if you looked at the solution to solve. All right. So what are the takeaways I got from this? The takeaways is that this problem really matters is the checking the total even sum, the rolling sum. And that what really matters is that if it's even, if the current value is even, we subtract the current value, then they update it, then they checked if the new value is even, and they update a rolling sum. So the trick here was just making sure that you just had to check if the current, so if you had to like summarize the takeaway, it was like use a variable to keep track of current sum, check if your current updated value is even, update your value, then update your current value again. Okay, so if your current value is even, update it, update your current value, then update your total sum. Update current sum by subtracting, then updating, then subtracting. I actually don't know what to put for the takeaway for this. I'm actually not sure. Update the current sum. I guess the key takeaway is that the only thing that mattered here was that if the current value was even or not, because that would affect the rather even sum. Right? Yeah. If their current value is even and your new sum is even, that affects your rolling sum. Oh, okay. So if their current value is even and the new sum that you had is even, that would affect the total even sum. Okay. So if the current value is even, what else? What was it? Current value is even. And the subtract rolling, okay, fine. I'll just subtracts total sum, current sum from it. If it's, then check if the new value is even, add current sum to it. If new value is even, new updated value is even, add current sum to it. Okay, I think that'll be like a key takeaway. I don't know why that just like did that. Okay, analysis. I wouldn't say I learned much from this. Analysis would mostly be like what I took away from this problem. Yeah. So like doing this would actually help you like remember how the solution's easier if you keep track of like all the values like this. Pin chat. Okay. Yeah. Doing it this way like allows you to keep track of it easier. But yeah. So yeah, let's go back here. Analysis if even rolling sum is even sums affect rolling sum, I guess. I don't know. Even sums. I don't know. I think that would be like a good analysis. All right, let's do the second problem. This one I think I already know how to do. But yeah, okay, given array nums and integer k, return the number of non-even subarrays that have a sum divisible by k. Non-empty subarrays that have a sum divisible by k. Subarray is a part of the, okay, so seven subarrays with a sum divisible by k equal 5. Okay, so to do this, you just use a prefix sum. And then just subtract. Wait, no, we don't need to subtract. Can you use 2 pointers? Seven subarrays here. Yeah. We use a prefix sum. Go through every single k subarray and then subtract your difference from it. Yeah. Okay. So here. Why is my pen not working? I don't get it. I just charged this like 5 minutes ago. Oh, holy shit. Yep, on the next, Maximus. I like your name, Maximus. Okay, so here, let's just... How satisfied am I with paint? I don't know. Did I just X out? Did I really just X out? Oh my god, I just X'd out of it. Holy shit. Man, I'm stupid. Okay, on to the next one. Okay, so we're just going to keep track of a prefix sum, and then we're just going to subtract each difference from it. This is like a really common problem on code forces, actually. So let's say we had 4, 5, 0, -2, -3, 1, and then k is equal to 5. So let's keep a prefix sum. So 4, 9, 0, 9 plus minus 2 is 7. 7 minus 3, 4. 4 plus 1, 5. Okay. Okay, so we have our prefix sum. We're just going to go through every difference of it and see if it's divisible by 5. So if we had 5, oh, this should be 9. What am I doing? Okay, so 4 plus 5 is 9, 9 plus 0 is 9, 9 plus 9 is 2, 7, 7 minus 3 is 4, 4 plus 1 is 5. Okay, so now we're just going to go through every single of these. So here, 7 minus 4 would give you subarray size k equal to 4. Wait, no, 4 minus... Wait. What's going on? 4 minus 4 is 0. Oh, okay, yeah, that makes sense. So if I take this 4 and I minus this 4, they'll give me the sum from here to here. Is that considered? Yeah, okay. Then if I take this minus this, 5 minus 4 would give me the sum from here. Okay. So yeah. Yeah, we're just gonna go through here and then, well, the last sum is obviously divisible by it, right? So maintain prefix sum. Subtract this from 0. Here for here, here for here, here for here, here for here, here for here. Yeah, I think that'll work. Go every 5th K, I think. Let's see. So let's see. This is 5. And this 1, 2, 3, 4, 5. 5 minus 9 would give me -4. So that's this. No, that's not right. I think we have to like subtract from here though. 9 minus 5, 5. 7 minus 4. 4 minus 4. 5 minus 4, 1. And here would be 9 minus 9, 0. 7 minus 9 minus 2. 4 minus 5, which is 4 minus 9. 4 minus 9 is -5, which is this. Oh, yeah, okay. All right. So yeah. So here we're just going to loop through, create a prefix sum, then we're going to go through every pair ij, and then just subtract from it, and then we're looping down, and if it's divisible by 5, we increment. Okay, so prefix sum. I actually forgot how to do this. I think it's like that. Then it's like prefix at 0 is going to equal to nums at 0. And then we're going to loop from 1. Sum plus equal to that, and then we set equal to that. Okay, so sum plus equal to nums at I, and then we set equal to sum. Okay, and then yeah, and then once we have this, we're just going to use like and we just subtract actually prefix. Then if it's divisible by it, we increment count. And here I think we just return. I don't know if this will TLE. To be honest, I'm not even sure. Wrong answer. 6. What am I missing? Oh, maybe the original number? Right, yeah, okay. Did I find any original numbers that are equal to 5? Okay. If prefix is divisible by k, we have to increase count also. Did I double count now? Hopefully not. TLE now. Oh, wow. Oh, boy. Okay. Let's see how we can make this faster. Okay. I guess we could keep a track of this in the first place. We could put this if statement here. I don't think that'll improve the speed that much, though. Oh, wait. I removed the variable. Okay, that's still TLUs. Okay, so the issue is not that. The issue is this. These two nested for loops. So we gotta figure out how to do that. Want to try this? Hey, what is Kusha Chahan? Is that how you pronounce it? Kusha Chahan. Yeah, I need to go to YouTube Studio. I don't even know if I'm live streaming really. Do. Want to try this? Yeah, on to the next. That's what it's about. Go live, I think. Go live. Not receiving enough smooth video. Oh, damn. I have a few concurrent viewers. Okay, so our issue right now is that it's TLEing because of this prefix. But I think if you were to go through every subarray, it would still TLE. Pretty sure like prefix sum is the answer though. Let's see. Okay, so if we do 5 minus 4, we get 5. And that's this. Sum. If we do 9 minus 4, we get 5, which is also the sum here. If we get 7 minus 4, we get 3. Oh. Okay. We could break when it's not divisible by it. So when this is not divisible by it, we could break. Right? Because we only need to continue it while it's divisible by it, right? So like 9 plus 5 is 4 plus 5 is 9. Oh no, that still wouldn't work. Because then it'll stop at the total sum. For 5 minus 1 is 4. 4 minus 3 is 4 minus 3 is 7. Oh, what the hell? Oh boy. Non-empty subarrays. 0 is divisible by it. I'm trying to think. I'm pretty sure prefix sum is like the way to do it. Although I think there must be a way that we could not have to do this double for loop though. But although I'm not 100% sure. Subarray sum is divisible by k. Oh, let's keep thinking. 9 minus 5, 5k, 5. Oh man. Um. Oh, okay. Let's keep thinking. What could we do? Okay, if I have 9, if we start from 5 and we go onward, this is still 0 though. Okay, 9 minus 4 is 5, continue. 9 minus 4 is 5, continue. 2. 7 minus 4 stop. 9 minus 9 is 0, continue. 7 minus 4 is stop, okay. So it's 3. 9 minus 7 minus 2, continue. 4 minus 7 minus 3, continue. 7. 5 minus 1 is 4 minus 3. 5 minus 7 minus 2, stop. And then in the end, this would be 3. So that's alright. Oh, man. What if we do like 9 minus... Oh, wait. Maybe I should have added 0. Because then we get 9 minus 4. No, 9 minus 3. 9 minus 9. I should have added 0. So then I don't need that extra. I don't need this. Here, I'll push back a 0 in front of it. I think I could end place, right? Is that what it's called? How do I add a 0 to the front? Add 0 to front of vector in C++. There's an insert function. Oh, insert beginning 0. Okay, I'll just do that. Insert okay. Alright, that would fix that other thing, but it still would TL you though. That would fix the if statement. Yeah. This is a hard problem. We could optimize this a little bit more to put this in the beginning instead of doing it this way. But still, it would still TL you at this part though. So I could take this out and do like pushback. So then we don't need this. Still it just says still TLU though. Oh boy. Okay. What can we do? Check remainder available in prefix. While we're iterating through, if not divisible, check remind. So if you're saying 9 minus 0, 4 is not divisible, right? Check remainder of prefix? It's like 9? We still have to check the remainder, right? What do you mean, like, take 4 divided by... Oh, man, this is a hard problem. Nine minus 0 gives me 4. 9 minus 0 gives me 5. 9 minus 7 minus 0, 7. 7, 3. Oh, man. 7 minus 0 from here gives me 7. 4 minus 0 gives me 4. Yeah, 7 minus 2 is 4. 5 minus 0 gives me 5. Okay. So that's from here. If it's not divisible by it, check the remainder. I don't know what that means. Oh, wait. Do you mean like move the index? Give link of spreadsheet, please. Okay. This is like, honestly, like I don't even know if I can make this spreadsheet like visible. Can I make this public? I don't even know. Can I make this? Can you even see this spreadsheet? I don't even know. There, I posted it in the chat. Let's see. Okay, if return the number of non-empty subarrays that have sum divisible by k. All right, if it's not divisible by k, man, I'm having like crazy ideas right now. I'm thinking like, if it's divisible by k, we could do like a binary search, but that doesn't make any sense. If it's not divisible by k, do we just break? I don't know. Would that work? I don't think it would. Yeah, that's the wrong answer. It gives you 3. Not divisible by k. What if we have 2 pointers? So we have a pointer in the beginning with our prefix. So we have this and this. This minus that. If it's divisible by it, then we move this down. If it's not divisible by it, move this up. 4 minus 4 is 0. So it's divisible by, we move this down. If it's not divisible by, we move it up. Nine minus 9, 0. Wait. I have no idea. I don't know what I'm doing. We could try that. I have no idea what I'm doing. I have no idea what I'm doing, honestly. Okay, wait. You have 0. How did I... Okay, wait. 5 minus 0 is 5. Divisible by it. We move the second one up. Oh, no. We move... Yeah, move this up. 5 minus 4 is not divisible by it. Move 5 down. 4 minus 4 is divisible by it. We'll move this up. 4 minus 9 is divisible by it. You'll move this up. 4 minus 9 is divisible by it. Move it up. 4 minus 7 is not divisible by it. Move it this down. Okay. Maybe that'll work. Hopefully this works. I really don't know what I'm doing at this point. If prefix at j minus prefix at I is So let's just see diff. We'll call this. If this is divisible by k, what did I say? Move the starting value up. Oh no, wait. 5 minus 0, move starting value up. 5 minus 1 is not divisible, move this down. 4 minus 4 is divisible by, move this up. 4 minus 4 is divisible by, move it up. 4 minus 4 is divisible by, move it up. Okay, so if it's divisible by, move I plus plus. Else, move j minus minus. And then here we're going to do count plus plus. And maybe, hopefully this works. Still wrong. Damn, I got 4. Damn. I thought that would work. Crab cakes. And what sum can we subtract to make divisible? Is asking access. Yeah, let's see. How do I make this public? Oh. Oh, whoops. Here, I made it public now, okay? Although I don't even know what, like, why would you want my spreadsheet though? Here, I made it public. Okay, let's see if we okay, so the 2 point didn't work. And but you have to multiply by something. Maybe it's like a count thing where it's like you got to take a number and then multiply by I. You know one of those things where it's like if it's divisible by it, then you got to multiply it by some j minus I or something really dumb. That's what I think. I think it's something like that. So like so like let's say it was like from here to here, right? Or here to here is divisible by it. 5, 0, minus 2, minus 3. So because of that, the rest of the subarrays must be divisible by it, right? The smaller ones. So like 50 minus, oh no, that's not right. That's not right. 50 minus 2 is not divisible by it. 50 minus 2 is not divisible by 5. If it's divisible by it, we plus equal to we gotta think. This is like, this should not be that hard. This is not I bet you this is not that hard. Like I guarantee you this is not that hard. Because this shouldn't be that hard. Like let's see. Okay, if we take minus 4, okay, 450 minus 2. 450 minus 2. Let's see. I was asking if this makes sense. If it's not divisible by k, then what sum can we subtract to make it divisible by k? We can get it as a remainder, and then check if we have a subarray with that sum already. So if you're saying like if we multiply k, because so let's say it's not divisible by it. So let's say 9 minus 0 is 5. Oh, fine. 7 minus 0 is 7, right? So these sums are not divisible by it, right? So what can you do to make it divisible by it? You need 2. No, not 2. You need 3. So I don't know how that would help you. Oh, wait. 3, yeah, that would not. What if we had... Man, my brain is like farting right now. Okay. How long have we been streaming? We've been streaming for an hour. I'm so tired. Okay. It's already 2 a.m. I think I'm gonna head to bed. We'll try to solve this problem tomorrow. All right? And yeah, we'll try to solve this problem tomorrow. Rate, comment, subscribe. I'll check you guys later. Peace.